test is planned for this coming Monday, April 1st. So these problems that we're working with are all weighted average problems. So a weighted average, it says on here, it just means that in your set of numbers, some elements carry more weight or more importance than other values. So when you think of weighted average, think of your GPA. Your GPA is a weighted average. The higher your grade is, the more weight it has, the more, I guess, it brings up your GPA versus the lower grades bring your GPA down because they have less of a weight. So that's, I think, the easiest way to describe a weighted average because you all have a GPA and hopefully you know how that's calculated or understand how that would be calculated. But like I said, we're looking at mixture problems, work problems, and then distance problems. I do have interest on here. We're not going to look at interest between these 2 days. So mixture problems are first. 1 and 2 are examples of mixture problems, and you have seen these before. I know they're in Algebra 1. I'm not sure if we covered them earlier in the year, but there's different ways you can solve a mixture problem. So the way I'm going to show you today is not the only way this can be solved. Because we are in the rational equation chapter, I'm going to show you how to set it up as a rational equation. But if that's confusing too, if you're struggling with it, if you'd like to see a different way to set it up, I can show you that because like I said, there's many different ways you can set up a mixture problem. But as we read through this, if this type of problem seems familiar, it's because you have worked with these before. So example 1, we have Jimmy adds a 65% fruit juice solution to 15 milliliters of a drink that is 10% fruit juice. How much of the 65% fruit juice solution must be added to create a fruit punch that is 35% fruit juice? So the way I would set these up, I kind of make a chart of the information that I have. And this is how you can kind of set up your chart for all of these. All mixture problems have some original substance you're starting out with. In this example, you're starting out with the 15 milliliters of a drink that's 10% fruit juice. So that's your original quantity in this problem. So every mixture problem starts out with an original amount of something. The weight, if you think of weighted averages, the weight in these problems is the percentage of fruit juice, or if you look at the next one, the percentage of the brine that's in there. So the percentage is the weight. But that's our original. And then there's also something in these problems that is being added to that to then create a mixture, which would be the new. So what's being added is this 65% fruit juice solution. And then the mixture, the new, is the fruit punch. That's the 35% fruit juice. So the new in this case is the fruit punch, if you wanted to label that. But every one of these problems should have an original quantity of something that's being added to create the something that's new. And then I'm going to make kind of a table here. So I have those 3 rows, and then I'm also going to make 3 columns. So what I'm going to have in this first column is the amount. I'm just abbreviating amount here. So amount meaning, if you look again at the original, we're starting out with 15 milliliters of the drink. So the amount is the 15 milliliters. So amount in this case is measured in milliliters. You can actually put the 15 there right away for the original. Then each of these also has a percentage of juice. That's their weight. So I'm going to put percent juice in this column. And for percents, just make sure that you're writing them as decimals. So the 10% I would write as 0.1, or if you write it as 0.10, that's fine. And then if we multiply the amount of the drink by the percentage of juice, you will come up with the amount of juice. And that's also in milliliters. So if I multiply the 15 by 0.1, or find 10% of 15, that's 1.5. That means of those 15 milliliters, 1.5 of them are actually juice. Okay, so then if I fill in the information for what's being added, so Jimmy's adding a 65% fruit juice solution, so I know what's being added. The weight or the percent juice is 65%, so 0.65. I don't know how much is being added, though. That's what I'm looking for. It says how much of the 65% fruit juice solution must be added. So I'm going to call this amount X. I don't know how much I'm adding. And then what I'm trying to create is the 35% fruit juice, which I'll come back to that 35% in a moment. So here for the added, if I multiply these, if I have X milliliters and 65% of that would be 0.65X. And then I'm not going to write the 35% here. I'm going to black this out. Again, I'll show you where I'm going to write that. But I can come up with these two amounts for my fruit punch, for the mixture. So think about this. If I am combining what I had originally and then I'm adding something to it, these are being added together. So if I had 15 milliliters and I'm adding X more, then I have X plus 15 milliliters of my fruit punch, of my new juice. And then same thing over here, if I have 1.5 milliliters of juice and I'm adding 0.65X to it, then I just have 0.65X plus 1.5 milliliters of juice out of the X plus 15. And then I'm going to show you kind of the formula we're going to use so you can see how to set this up as a rational equation. So I know I added this middle column in here to help you realize where this is coming from. But I do want to show you that if you take the amount of the juice and you divide it by the amount of the drink as a whole, that's equal to your percentage. So 1.5 divided by 15 is 0.1. It is 10%. So the percent of the juice is equal to the amount of the juice divided by the total amount of the drink as a whole. And this is what I'm going to use as a way to set up an equation that I can solve. I do also want to say, because in the next example, we're not actually dealing with juice, we're dealing with brine. So wherever I have juice written, that can be replaced with whatever your problem is talking about. So like the original, the added new, the amount, percent, amount, that can all stay the same. But wherever there's juice, it's just whatever the problem is, whatever quantity is in the problem. So because I want my new fruit punch to be 35% fruit juice, I'm going to put the 35% here. But rather than writing 0.35, I can write a percentage as a fraction. A percentage is just that number divided by 100. So 35 divided by 100 is 0.35. That is 35%. So I can write that as a fraction. And then equals, so in my fruit punch, the amount of juice is this quantity, so 0.65x plus 1.5 over the total amount that's in the fruit punch is the x plus 15. And here's an equation that I can solve. It's a rational equation because I have two rational expressions in it. Any questions on setting that up? Okay, now to solve this, or think of how we solved rational equations yesterday, you had to find the least common denominator, you had to multiply everything by it. You could still solve this one that way. However, this particular equation is actually a proportion because I just have one fraction equal to another fraction. So how can you solve a proportion? There's a different way you could solve this. Yeah, you can cross multiply the diagonals and set them equal. And you can do that for this one because of the way it's set up. So if any of our equations yesterday looked like this, we could have done that process. But yesterday we had multiple fractions being added or subtracted on the same side. Just make sure that these quantities I would put them in parentheses so that the 35 and the 100 get distributed. So I would have 35 times the quantity x plus 15 is equal to 100 multiplied by the quantity 0.65x plus 1.5. And now I can distribute on both sides and then solve for x. So I distribute 35, I'll have 35x plus 35 times 15 is 525. And then if I distribute 100, I would have 100 times 0.65 is 65, so 65x plus 100 times 1.5 is 150. And then solving for x, subtract 35x. So 525 is equal to 30x plus 150. Subtract 150. I'm going to continue this over here. And that gives me, I'm also going to switch this around. So 30x is equal to 375. And then divide by 30. And I will get 12.5. And then make sure you include units. So my x is representing the amount in milliliters of what's being added. So it's 12.5 milliliters. That's how much should be added of the 65% to make the mixture that they want. Okay, so mixture problems, like I said, this is not the only way to set it up. This is how you can set it up with a rational equation or a proportion, which then gives you, well, proportions aren't too bad to solve, but I know getting there, that's the challenge with these, is knowing how to set that up. So go ahead and look at example 2 and work through that one. Set up your chart to organize your information. Like I said, you can just replace the juice with the brine in this case, the salt and water solution it's talking about. But give example 2 a try. I'll walk around in a moment. I will admit it was much better. Still bad. Okay, I know some of you might still be finishing those up, but either check your answer or make sure that you can get this answer, that you're on the right track. So 21.3 repeating, if you have 21.3, 21.33, that's fine. 0.3 repeating is a third, so 21 and a third would be the exact answer, but having that decimal is okay. Okay, so I know word problems, I know are tough because you have to be able to take the information and set up the equation to solve it. So just make sure, I have one other example to go through with you, one for you to try with the work problems, and you'll have some time to work. So just make sure you're letting me know if you have questions. Even on this, if you're not quite done, if you want to kind of come back to that, try to look at where you were at the time I walked around and make sure you were on the right track. So we'll go over work problems. And again, work problems are, it deals with rates. So the rate at which a person or rate at which people can do some sort of given task. So a rate meaning how long it takes them. So I'm trying to think of how to phrase this, like something in terms of time or something with respect to time. Which you'll see here, you're setting up rates. So in example 3, it's talking about 2 people raking leaves as the example. So it says it took Anthony and Travis 6 hours to rake the leaves together last year, and the previous year it took Travis 10 hours to do it alone. How long will it take Anthony if he rakes them by himself this year? So I am going to set up 3 rates. So we have Anthony, so I'm just going to put A, we have Travis, and then we have Anthony and Travis together. So I have A, T, and then A plus T. So here's how you're going to set up the rates. I'm going to go back to the beginning, and it says it took Anthony and Travis 6 hours to rake the leaves together last year. So think about it this way: if it takes you 6 hours to do something, then each hour you are completing 1/6 of that task. So if it takes you 6 hours, you are completing 1/6 every hour. So their rate, Anthony and Travis together, their rate is they can rake 1/6 of the leaves per hour, because it takes them 6 hours to do it. Okay, so then for Travis, it says the previous year took Travis 10 hours to do it alone. So if it takes Travis 10 hours, then each hour he's completing 1/10. So Travis's rate is 1/10 of the leaves per hour. And then we're looking for how long it will take Anthony if he rakes them by himself. So if I let x equal Anthony's hours, or Anthony's time, then Anthony's rate would be 1/x. So he can rake 1/x leaves per hour, or do 1/x, that fraction of the job, in 1 hour. All right, so you're setting up rates for each person or the people combined. Then for your equation, and hopefully this makes sense too, that you should take Anthony's rate and Travis's rate. If you add these together, you should get their combined rate, just like A plus T should equal A plus T. So if I take Anthony's rate of 1/x and I add it to Travis's rate of 1/10, that should equal their combined rate of 1/6. And that's how we take that information to create a rational equation. From here, this equation does have to be solved the way we did it yesterday with finding a common denominator, because you have these two fractions added together on this side, so you don't have a proportion. We can't cross multiply for this one. So we need a least common denominator, or just a common denominator. What was it? 30x would be the least common denominator. So they would all need an x, and then 10 and 6 both go into 30. You could use 60. It would also work. It doesn't have to be the least common. As long as it's a common denominator, it works. So then I would multiply everything by 30x. And again, it's 30x over 1. So the bottom does not get multiplied by the 30x. And you should be able to cross simplify so that your denominators all simplify to 1. So in that first term, my x's cancel out, and I just have 1 times 30, so 30. In the second one, the 10 and the 30 can simplify. 10 becomes a 1, 30 is 3. So I have 1 times 3x, so 3x. And then the 6 and the 30 can simplify. 6 becomes 1, 30 becomes 5. So 1 times 5x is 5x. And now I can solve for x. So subtract 3x. So 30 is equal to 2x. Divide by 2. And x is 15. We are measuring how many hours it took Anthony. So it's 15 hours. If he had to do that job by himself, that's how long it would take based on the other rates. All right, questions on that? Okay, so try example 4. Noah and Owen are painting houses. And then I'll pass out the practice for this, and you have some time to work on that or ask questions from the notes, or if you have questions from yesterday, ask questions from yesterday.
You said it at the same time. Yeah. Because like for Noah, it's 6 days, you do 1 over 6. It's like how like in the first one it covers 10 hours. So you put it 1 over 10. So we would just put these under 1. Sorry, under. I got dusted.
So, because it's saying if it takes him 6 days, then each day he's doing 1/6. And if it takes him 5 days, each day he's doing 1/6.
So it is supposed to be square.
Yeah.
So it'd be.
You said over.
Wait till we can set it up.
Yeah, because it takes him 5 days, then he's doing 1/5.
So we were no, that's what came supposed to be 3. So it's 5. 11. Yeah. Oh, I thought you were here. I thought you were where I was. That's not where I was. And then would you add
I know. That's wrong. Oh.
Yeah. But if y'all I know you know. Fine.
If you didn't quite have the answer, I have it on the board for that one. You do still have about 3 or 4 minutes. If you have questions, let me know. Hold on, you guys. You still have a minute. Hold on. Just wait, you guys. No, class is not done. All right, you can go.